Okay, hello everyone. You asked me to do a video from section 4. So this is from section 4.3, sort of the second part with higher order derivatives, and you wanted another example like we did in class. I'm also going to upload, I think, some notes, some review notes from the rational zero test, so you can look at that. Purplemath.com is a good website. If there's some algebra topics that you all need to review, you can check that out. But so you just need to remember that to find a zero, we first start for something that's third degree or higher, because if it's second degree, you can just use quadratic formula or factor it or however. But it's third or higher, then it's something called the rational, I think it's called the rational root test. But remember, it could be called rational zero test or solution, or roots, zero, solution, and x-intercepts are all the same thing. Okay, and so here what you do is remember P is your constant term and Q is your coefficient. Okay. And you take the factors of both numbers. So in this case, P, the constant, is -6, and Q is 1. So it's plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then for 1, it's just plus or minus 1. And then to find all the possible rational zeros, you take the ratio of P over Q. And I guess I mean the factors, the ratio of the factors of P and then the factors of Q. And this is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all over plus or minus 1. Now, here's the thing. If Q is just 1, then it's just going to be plus or minus 1. And so your answer will just be all the possible numbers in the numerator. Okay. And so what this test tells us is if there is a rational zero, it has to be one of these numbers. And there's a total of 8 numbers there. It has to be one of those 8 numbers. I always say start with 1 because you could just plug it right in to see if it's going to work. Or you can eyeball 1. -1, you got to be a little more careful because if you square it and if you're raising it to an odd power, it's going to stay negative. If you raise it to an even power, it's going to become positive. But 1, you could sort of eyeball. So I can just look, and when I say eyeball, I mean you could just sort of plug in 1, look in there and see what's going to happen. Because for 1, the signs will stay the same, right? So it's just going to be 1 plus, and it's really 1Q. I want to make sure that's clear, but that's just 1 plus 2 times minus 5 times 1 minus 6. And so that's 1 plus 2 minus 5 minus 6, which is not going to give us 0, right? It's going to give us, what's that, 3 minus 11, -8, looks like. And then -1, so I would just plug those straight in to see what's going to happen. Okay, and we see from there, we're going to get -1 plus 2, right? Plus 5 minus 6, which that is 7 minus 7. So -1 is a 0. All right. And so I wanted to, wait, hold on a minute. Okay. So this is sort of a side. So you don't have to write this down, but I want to make sure we're clear. Let's say if P was 12 and Q was 3. Okay. Well, and again, you don't have to write this down. I just want you to see how to sort of think about writing your possible ratios. Okay, so P over Q. Well, what's the factors of 12? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, right? And this plus or minus 12. And then 3 plus or minus 1, plus or minus 3, since 3 is prime, and its factors are only itself in 1. Okay. And now when we think about it, so you can look at it, so now you take the ratio, you can look at it a couple ways. You could sort of, since it's plus or minus 1, we know that the possible rational zeros will be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, and plus or minus 1. Where did I get plus or minus 5 from? Just thought we were going in order. No, 5 is not a factor there. Plus or minus 6 and plus or minus 12, right? And so because that's, you take the ratio of each of your numbers, right? So if you take it 1, it's just going to be the numerator. But now that we have something other than 1 in the denominator, you have to take those ratios, right? And so that's what that'll look like is now we have plus or minus 1/3, plus or minus 2/3, plus or minus 3/3, but 3/3 is the same as 1, plus or minus 1, so we already have that taken care of. Don't repeat zeros, right? Plus or minus 4/3, plus or minus, 6/3 is the same as 2, plus or minus 2, so we have that, and then plus or minus 12/3, which is plus or minus 4. So we're actually done after this. Okay, so now how many total possible rational zeros do we have? 2, 4, 6, 8, 10, 12, 14, 16. So there are a total of 18 distinct possible rational zeros. All right, so I just wanted to make that clear in case you have a number other than 1 in your denominator as your because remember this represents your leading coefficient, right? Okay, now let's get back to our problem. Okay, so remember we found that -1 was a 0, and since that is a 0, we can do synthetic division to help us find our other roots, right? So -1 or long division is up to you. Remember, so we did this in class. So this is 1, 2, -5, -6, right? We took the coefficients. All right, bring down our 1, and then we do the algorithm for synthetic division. 1 times -1 is -1. Add vertically, so that's going to be a positive 1, and just repeat that process by multiplying by our divisor. That's going to be -1. That's going to be -6, and that's going to be 6, right? Because we know that -1 was a 0 or a solution or a root, then we automatically know that because that last place always represents our remainder, so we know that means that the remainder should always be 0, okay? If it's not, then either -1 is not a root or we did something wrong in our math, okay? And so now we look at this new polynomial here, which when I read it, you can read it from left to right so you'll know sort of what degree, because -6 is going to be your constant, and then x, and then x squared, okay? So x squared, or we're dealing with m, right? I'm sorry. So it will be m squared plus m minus 6, okay? And then now it's a second degree polynomial, so we don't have to go through the process again of trial and error. We can just use quadratic formula or factor it. This one should factor nicely. M, that's m, so what will it be? I think positive 3, right? Because there's a positive here, and then -2. All right. So m equals -3 and 2. Remember that m equals -1 is also a solution. So we found all our solutions, right? So our general solution then is just y of x equals c1 e to the, I actually included the -x first, but you can write it however you want. This is how I wrote it in my notes, so I'll keep it consistent. But it's up to you where you want to place your constants and which exponents you want it with. Okay. Now, if this was not if this wasn't an initial value problem and they just asked us to find the general solution, we would be done, right? Okay. But this is an initial value problem, so we have to take it a step further. All right. And so since we're taking it a step further, then we know that we're given, what are we given? We're given that y of 0, which is equal to y prime of 0, they both equal 0, and then y double prime of 0 equals 1. So therefore, we need to find the first and second derivatives, right? And so you can double check my work here. These, I believe, are correct. So you can double check my work and make sure. If you have any questions, you can, next time you see me in class or come to my office hours, you can let me know what questions you have or email me. But there we have that, right? And so now we can just plug in, which I have it. Okay, yes. So I already plugged in our values. Y of 0 is 0, y prime of 0 is 0, and then y double prime is 1. And there we have 3 equations because we have 3 unknowns. So we can solve this by systems of equations. If you have taken linear algebra, you can just throw that in a matrix and do some row reducing and solve for your constants that way. If you have not, you can just do some, regular substitution or take 2 equations, processes of elimination. It's really up to you on how you want to solve these, okay? And so you can do that. Your final answer, C sub 1, did I have that? Oh, no, that's C sub 1 should give you -5/2. No, that's not right. That's something if you do the substitution. C sub 1 should actually give you -1/6. And so keep in mind, too, if you did not write your variables in this format, like if you didn't write your equation this way, then your constant C sub 1 might be what C sub 2 is or something like that. But they should still all be the same values. Okay, they just might be for different constants if you use something different. Okay, so I hope this makes sense. Now I'll say this, if you're not for sure how to solve systems of equations, then you can go to purplemath.com and like I said, any type of algebra that you need a quick review on, you can do it that way, okay? But make sure you're good there, okay? All right, we are done with this video. I will see you in the next.